Hey, Ryan.
Hey, what's going on?
Hey, and
How are you?
looking at some parts we have here that we've been making mini isolation plates out of in part of our jack clamps.
Sure.
Trying to find a better use for it because we have plenty of these in stock.
Right.
Hundreds and hundreds of them.
Right.
Thinking of a bottle opener kind of thing.
Huh, that's a great idea.
Saw that picture online, thought something, you know, maybe not like that, but just to get the ball rolling and
Wow.
what we can come up with our logo to have a keychain bottle opener made out of this scrap material.
So we got plenty of these parts.
Plenty of them.
And this is just a blank slug that cuts out of another part.
Normally that's been all waste in the past. We started putting isolation plates in there, but we have
these,
literally probably thousands actually, more than hundreds.
Oh, wow.
So
got it.
I want to back off on that.
Yeah, that's a great idea, Bill. I'll talk to Galen about it right away and get a design going for it. That's a great idea. So you have these for years?
Yes.
You don't have any more of those.
We won't run out of mini isolation plates till next year sometime.
So instead of making this part, we'll make some nice keychain or something for our customer. Yeah, that's great. And I'll show this picture to him.
And maybe we'll do some powder coating or whatever.
Great idea. Yeah, that sounds great. All right, stay tuned. We'll see what he comes up with.
Sounds good.
All right, thanks, Bill. Hey guys, welcome. We're here with Galen. We're here in our design and build series. We're going to show you a little bit about how we design and build and manufacture products and items. Galen, what's going on here?
Right now I'm just finishing up on our new bottle cap.
Okay. So what tell me what transpired here, what's inspired this, what's going on?
So basically I was brought this slug of steel, and since we have all these isolators, we don't need many more right now, so we're going to replace it with a bottle opener.
So basically, guys, this is one of the pieces of scrap steel, and we were cutting these small parts out of it, which was a mini isolator plate. We're no longer going to cut, we have plenty of these, we have enough for a lifetime, so we're going to change this file and we're looking for another new part for in here. So Galen's designed this bottle cap for us. More of a keychain type of bottle opener, and he's gonna put it in the inside of this, and then it's gonna go over to engineering, and they're gonna actually engineer the part, 3D the part, and then it's gonna go to programming. They're gonna program the part. We're gonna show you all that all along the way and show you exactly how a product's built. So from a need to an idea through to a design on to an actual product brought to you. So stay tuned. Anthony, so you're here at the hot box here in the design and build series. What exactly is going on?
Galen just sent over a DXF for a new bottle opener. We have this little part we cut for every Nugsmasher unit, and it's excessive waste with our laser and our materials, so Galen designed this logo.
Who's Galen?
Galen's our graphic artist.
Okay.
He's the one that designs all our, logos and the brand and all that stuff. The stuff that you really see from Nugsmasher in terms of graphic arts.
Okay.
It comes from Galen.
So he sent this over. You had a spot, and you said in one of the pieces of steel that we cut out of a unit.
Yeah, so this will fit right in that little spot. That's a little waste, so we could now start producing these little bottle openers. And I was just going through and getting it ready to cut. So I'm like rounding all the corners and making sure the corners are good so they don't cut anybody and all that type of stuff.
How thick is that?
This is 11 gauge steel, so it's about
I can see
it's
this
about an
3D
1/8
now.
inch, in terms of thickness.
Okay, great.
It's
well,
about,
and when are you
inch
going to cut this?
Whenever we need to cut it. I mean, it's probably gonna be cut within today or tomorrow. So.
Okay, well, stay tuned, guys. Guys, we're here with our design and build series, and we're here with Christian. Now, if you've joined me previously, Bill came to me a few mornings ago and said, hey, we got some empty space in one of these parts, and we want to put something else in it. His idea was a keychain. Obviously, it went to engineering. Anthony designed a keychain. You saw that little segment where he did that. Now, after the design's done, we have to be able to manufacture that keychain. So that's where Christian comes in. Christian, tell us a little bit about what you do.
All right, so I take this part here. This is Anthony's design in SolidWorks. What I do is I save the DXF. I'll pull the DXF into here. It's AP100. This is to program the laser here. So I have it programmed right here on a REM sheet. We'll cut a test part here in a second, and then write the NC code and save that over to the laser there.
So the NC code, that's what actually tells the machine what to do, right?
Yeah,
the software is just to really get it into that code. Is that correct?
That's exactly.
So now you got a sample in there, and we're going to go to the laser and see what happens?
Yeah.
Okay, let's go down there, see what happens. As you may or may not know, we're in the city of Lake Havasu here, and we what we did is we were looking for a much larger space because our product was really topped out in our factory in Corona, California. So we sought out this location. We love the city and the area here, and we ended up buying the old Kmart here in Lake Havasu. So that's a lot of our factory, our whole factory. Most of the manufacturing is done in this old Kmart here. So that's why you see things that look a little familiar. We love this old building and what the factory brings and offers for us. So you can see the machinery that we've set up here and the investment we've made, and it's all really to build our Nugsmasher parts, assemblies, and final goods. This is a Insys 3015 AJ. It's a 9 kilowatt fiber laser machine by Amada. These are made in Cerritos, California, at the Amada factory there. It has an automation tower on it that handles our different steel. So Christian can actually set this machine to run overnight and let it run all night, and it'll just keep producing parts, taking them on and off the machine itself. You can see it goes way up into the ceiling there, the automation. So what are we doing here, Christian? We're just cutting a test piece, correct?
Yeah, we're gonna cut one little test piece, that bottle opener there, and
make sure it works okay.
Yeah, we're gonna cut it on a REM sheet here. So I just put a 10 by 10 sheet of 11 gauge steel in there.
Now, for people that don't know, how thick is 11 gauge steel?
0.12, so it's about 1/8 of an inch.
About 1/8 of an inch thick, 0.12 of an inch in measurement. And that's the thickness of the steel he's cutting. And it's just a regular old mild steel.
Yep. Do that. Draw mode.
The parts that this machine puts out, guys, is absolutely amazing. High precision machine. One of the parts, I was using an example, we use in the touch, it's the backing plate for the touch that holds the actual circuitry. We cut an actual 3mm thread in the post of this on the flat program. So this, to give you the accuracy of that, you know, I know a lot of people don't know what the 3mm is. It's just a tiny little itty bitty thread that we cut in a flat post. He's cutting this now, so let's see what it looks like.
Just handle jogging it right here to tell its start point.
So that's our test piece. So Christian, if this comes out right, what's our next step?
Our next step would be to nest this into the jack clamps that we have here. There's a little space in between them where the jack actually goes, and we can nest 2 of those in there. So we should be able to get, I don't know, roughly 300 to 400 per sheet.
Per sheet, that would just be wasted steel otherwise.
Absolutely, yeah.
Badass.
So micro tip, pulling it. It's a little hot, so.
Well, I'd say it's pretty good. Excellent. So when will we have these nested in this piece to show the viewers here how that looks?
You know what? I actually already nested them to see if they would fit prior to cutting this, because that
Oh,
was a
you
big
did? Is
thing.
it in the machine here?
It is in the machine already.
Wow,
Yeah.
can we run it?
Yeah.
Oh,
yeah, we can
wow,
run it.
let's do it.
Yeah. You want
Yeah.
me to, all right, I'll load a sheet of steel then,
Yeah.
and we'll run it.
So basically now he's going to load a sheet of steel. He's going to bring it from the tower here, the automation tower you see poking up through the ceiling. And he'll bring a piece of steel. So it's a whole sheet of this big, thick steel, this plate.
So I actually have the 11 gauge down here already. I'll pull it back up. It's down here, but I can pull it back
So
out.
if you come around here, you can see. So he's got the steel sitting down there, right? He's going to take a piece of that thick steel with those suction cups, and he's going to put it over on the table. And like I said, if he's doing a bunch of pieces, a bunch of sheets, he can do this automated, so it'll run all night, one sheet after the next. The fingers back there will take the parts off, whatnot. It's really an advanced machine, really a great machine for production. So works real well for us. You can see the shuttle table back there is coming out of the laser that's over there. It's sliding underneath this other shuttle table that's in there. You can see the top shuttle table is lowering now. It's sliding in the actual machine. Now the traverser is going down to pick up a piece of 11 gauge steel. Hey, Christian, how heavy is a piece of 11 gauge steel? Do you know?
One sheet,
One sheet,
so probably roughly around 300 pounds.
about
or so.
300 pounds of steel. So maybe a little lighter, but too heavy to lift up. That's for sure.
Oh yeah.
So
yeah,
it basically
no, we're
brings
not-
it up. It shakes the sheet because sometimes the other sheet gets stuck to it. It'll test the thickness of the sheet. See the little tester over there to the left. Brings it all the way up, and then it'll bring it over on the actual table. So it slides it over. Now it's going to set it right down on the table. And once it does that, it'll send it in the machine. Okay guys, now the actual steel is in the laser now, so we're gonna go check that out. So you can see the whole sheet is now in the actual laser, guys, and we're looking through a piece of glass that protects us from the laser beam. So it's a tinted piece of glass, but you can still see what's happening there. Now the head's all the way back at the corner. Christian's loading the program over here on the actual machine. And what is this? What is the program? This cuts a different part, not the part we're trying to cut here.
Yeah, so
but
this originally was just a jack clamp program.
Okay.
So I was cutting 102 jack clamps per sheet. We bend those up, and those are basically to hold the jacks inside of the units for the XPs, the OGs. But we were wasting a lot of the steel because there's a slug cut out in the center of that. So, you know, you guys came up with the design, which is this here.
And before that, we were cutting mini isolator
Isolation plates. Yeah, we got about 6,000 of those
Okay.
cut though. So,
So
we
we have
don't
plenty
need
of
any
those.
more of those.
Yeah.
Yeah. So this here is actually going to replace that. We're able to get 2 of these as opposed to 1 of the isolation
Sure.
plates as well. So might take a little while. It's nested pretty tight.
Yeah.
So it
Yeah.
takes a little while to load sometimes, depending on how big the program is.
There we go. You can see the screen, so that's all the cuts it's going to make on that whole sheet.
You can see here what that slug that we were talking about there.
So the actual part is this purple line or this blue line is the actual part. Everything else is a cutout. So these slugs are what we're utilizing, this round slug that's a waste in the center. machine's coming and it's detecting the size of the sheet, so it knows exactly where the edges of the sheet are. Make sure that it's put on exactly straight. So it's adjusting that. It's coming over to this corner. And then typically what will happen, the machine will change its head or clean its head along the way. You can see it'll get started. Now, how many minutes is this program? It's about an hour or so, or less?
I'd say roughly around an hour.
Okay.
Like I said, I've never cut it before, so we're gonna see how long it
So
takes.
starting
here.
out with the first keychain there. So, and like I said, the program's about an hour, so we're probably gonna take a break and come check. We'll let it cut to this first one here. We'll take a break and then we'll come check in a little bit. Pretty intricate part. And you're kind of wondering how those slugs, why some of them fall out and others don't. He can program those slugs to cut out or cut up in little pieces, or to put a micro tab in them so that they don't just fall out, that they can be held in the sheet until we take them out at the end with a power hammer or something of that nature, or tab them out. So that's there's a lot of computer work building these steel parts. Pretty amazing. Isn't just some dummy making steel parts. This is a computer engineer's job today. So, all right, guys, we're gonna come check back here in about a half hour, 45 minutes, see where we're at, and. Christian, we'll come check back in with you, okay?
All righty, sounds good.
Thank you so much.
Thank you.
Christian, we're back, and did this sheet actually cut? Did it take an hour or so to cut? Or
Yeah,
what
right around
happened?
an hour and cut through the whole entire sheet. Yep.
Okay, great, guys. So basically what's happened is we're here with Bill and Christian. We got an idea from Bill on a part that we had too many parts of. We were using a blank that was basically wasted steel, that we were cutting small parts that we have a lifetime of. So Bill came to me and says, hey, let's do something else with this. I like a key ring, and he gave us some ideas and whatnot. Then we gave the design to our design team, Galen. He started designing and whatnot, and he gave us a design that we all agreed upon. Then the deal went over to Anthony to engineer, and then he did some engineering on it and got the part just right. And then it went to Christian to actually make the part, actually program it, cut it out of the laser. We showed you how to do that. Now what's happening is this is the actual whole sheet that he cut. So let's see it. Oh, shit. Got it. Wow. So Christian, this is the actual part, right?
Yep. Kind of tricky to get them out sometimes.
So that's the actual part that gets bent up and whatnot, and then it has this slug in the center, right?
Yep.
So these pop out of there like that. There you go, Bill. And then this is the actual real part that we're trying to get.
Yep.
And this is just use of the steel here.
Sure. Yep.
Really nice. I think our customers are really going to enjoy these key rings and bottle openers. Now, what, Bill? Now that we got all these, what's the next step? What do we do with it?
Yeah, so you want to get all these knocked out of the sheet, and then we'll tumble them. Get all this little deburr slag off of here, and that'll deburr them in the tumbler.
So
and,
any little imperfections, I guess he's talking about in there, right, Bill?
Yeah, correct.
And then we'll get them all tumbled up.
And then we'll take them over to powder coat.
Right.
And I want to try a couple different coats, from 1 coat to 3 coats, and somewhere in there. We'll see how they come out and what we like, and as it gives us the look we want, and then we'll go from there and just coat the rest of them.
Well, there it is, guys. There you have it from start to finish, and we'll show you an actual finished product, what the actual powder coat version looks like. But from start, an idea, Bill's idea to start with, all the way through the process, design and build, actually how it's done, right there. And you can see what goes into even just a little key ring. Right on.
All right, guys, here we are. We're here with Eddie. Eddie runs our machine shop here at the Nugsmasher factory, and he's going to show us the next step to take the slag off these, right?
Yeah, the slag.
There's some little bit of slag on the back side of these, right?
Yeah, slag, and there's burrs, some sharp edges and stuff.
So Eddie, share with us what are you doing? What's the next step on these things?
So basically, this is a vibratory tumbler. This thing basically vibrates. There's porcelain media in here. So we got different types of media, different size, different abrasiveness. So basically the parts get thrown in here, this vibrates, and then we have a detergent cleaner mixed with water that flows through here to kind of wash away any stuff that comes off the parts and gets caught in a bucket. So we'll put these in here anywhere between 2 and 4 hours, depending on how much burrs are on there and how finished we want it to look, you know. So the longer it stays in, the more of a like shiny, polished look it has. So
Do you put them all in at once, or how many can you put in there?
depends on the size of the parts, but we could put at least half of them in there.
Okay.
Normally, you just want to have enough room to where they're not hitting each other too much. So you kind of just got to go by feel a little bit,
Okay.
and also the capacity of the machine. You don't want to go over a certain level, pretty much this level here. So, but yeah, this type of parts are pretty durable, so they're not going to really hurt each other by hitting each other. But if we had like aluminum parts, we wouldn't want them all banging against each other, so we wouldn't want to have as many in there at one time. But
Got it.
you know, I can put at least half of these in there and see how it looks.
Are you ready to put them in now?
Yeah, so this thing's loud when I turn it on, so I won't be able
Okay.
to talk, so I'll just fire it up and just
Yeah.
start dumping these in there.
Yeah, I'd love to see it.
All right.
So as you can see, guys, the detergent in the back is the key to this whole process. And it really is like a big sander. It's going to polisher. It's going to polish all these parts, make them real smooth and nice, so they're nice to the touch and feel prior to the powder coat. So what he's doing now, he's kind of getting the judge a gauge on how many parts he can put in there, based on he didn't want them too tight and banging together and sticking together. He wanted to be able to make sure that the media can get in between them all and get them all clean. So let's go ahead and step out and we'll talk to Eddie about the rest of the process. So 2 to 4 hours you'll leave them in there?
Yeah, generally 2
Okay.
to 4 hours.
So, and then when they're good, you'll let Bill know and we'll come and get the powder coat and whatnot.
Yeah.
So next step, powder coat, guys. Stay tuned. Almost there to a finished product. And thanks so much for showing us what's going on. Guys, Eddie's an expert in finishing parts and parts finishing. He runs our machine shop here at the factory. So all the final machine products and parts that you see on our machines or that we turn out, our accessories, he's in charge of, and his team builds. So we thank him for all that. So anyway, see you soon. Hey guys, so we're back, and what's happened here is we're here with Bill and Chad, and Bill's going to explain to us what's going on here. We're in our powder coat department. So Bill, what's happening?
Yeah.
We take these out of the tumbler, right?
Right, exactly. All been tumbled, ready to go. They've already been preheated in the oven, which cooks out any oils or any other things. And then we'll rely on Chad here, who leads our powder coat area, to come over and put a good coat of clear on these and start get them back in the oven after we put the powder coat on them.
Great. And we're going to see that happen here. Chad's
Yeah,
going to
he's
do.
gonna
Oh,
spray 'em
okay.
right now.
Very good, Chad. Let's see what's going on. He has a copper rod on that, but
That way everything gets grounded. We don't have to worry about grounding through the powder coat on the chassis.
Sure.
There.
So guys, you know about powder coat, but it's just clear powder that he's spraying on that. Powder coat's just a powder that is conducted by electricity, static electricity. That's why he's got the copper rod that he's touching each of them with. That helps the powder adhere to the steel. And then what happens, you can blow it off the steel with your breath or with air until you put it in the oven. And by putting it in the oven, it bonds the powder all together and makes an outer shell that bonds it in the molecules of the steel, and it makes it a real hard outer shell finish. And that's what he's doing here. And we'll show you our oven and whatnot. He's sprayed these, and I think he's going to put them in the oven now.
Yeah, he does such a great job with us on this, has all the processes, procedures down, and he's doing a great job in our powder coat area.
Yeah, I know that the coating of the product has really come up since we moved our factory here, and Chad's been powder coating. So
Really has the design of our oven, all
yeah,
that.
he really cares.
Really great.
Really cares. As you guys may know, all of our products, they're guaranteed for life, so everything we do has to be done right. We use the finest powder coat, finest guns, finest material. We try to make sure that we're hand building everything, inspecting everything, so you get a really good finish and a really good product at the end. I think the camera's getting powder on it.
Yeah, I guess that's probably to get her out of there.
Hey, camera guy, come on out. This spray booth has big filters on one side that suck all of the powder into them. They're off right now because of the filming, but typically they're on. It sucks all the powder into them. And what happens at the end of the day, he can collect all the powder, put it back in the hoppers. They have big shakers on them, but that keeps the environment clean in the factory. So now that he's got them all sprayed, I guess he's going to put them in the oven now, right, Bill?
No.
Get a good look at this oven, guys. The oven is sitting at 387 degrees. These things will go in there for about, 10 minutes or so? 20 minutes. And when they come out, we're gonna see what the finish is like, see what the coating's like, see if it's worthy. And if it is, we have packaging for them. We're gonna slip them in the package and try them out. So stay tuned, guys. Thanks, Chad. Appreciate it. Hey guys, well this will conclude the end of our another design and build series, and what we have to do now is the most important part is test the product. So product's all packaged here, we got to test the product, we've got the team here that was involved with building it. Let's see what happens here. Let's see what's inside these things. Dig in, guys. It's a review of the packaging and the product, right? Yeah, those are legit. Smooth and nice, wow. Oh shit. How do they work? How are you doing, Jack? Are you? Like here, you leverage it like this. Yeah, okay. Alright. Alright, does everybody get it out?
There you go.
Galen don't need no fucking help. He chewed off with his fucking teeth. Right?
All right.
Cheers, guys.
Cheers.